Okay, so can we use a graphing utility to graph this function, determine where it's increasing and where it's decreasing? So if we graph the function, here it is. You always have to be a little careful when you're graphing functions, because imagine your window, your graphing window, was set to this. Then your picture would look like this. And you might think it just decreases forever in both directions, but a larger window shows it actually starts going up again. So graphing windows can be very misleading, which is why I don't like telling people to rely on graphing utilities. You have to have a good understanding of the actual math behind it to know if your graphing window is good enough or not. Now this function has an x cubed in it and an x squared, and that's it. So for abstract reasons that we'll get into later, I know it either looks like this or like this. Since there's a negative sign in front of the x cubed, I know it fundamentally looks like this, and therefore this graphing window has captured all of the information. But for now, we really don't know that. In theory, by expanding the window, we might see something like this, and we just don't know. But we're going to go ahead and assume that the graphing window was chosen reasonably. And I really want to stress, don't rely on your graphing calculator to be smarter than you, or you're going to misuse it and you're going to get wrong answers. So assuming this graphing window really captures everything, there are different ways to do this for different calculators. I forget which brand this book assumes you're using. I think TI's, and there's actually a maximum function. On different types of calculators or different programs, it'll work differently. But usually there's a way to find a local maximum. And if you have a different brand or you're using different software, you can always just Google like how to find maximum values on graph, or how to find local maxima or local minima. These terms are quite universal. So if you just look through your instruction manual or Google them, you should be able to find instructions. But anyway, this calculator will tell us that if I let x be 1.66 something or other, I'll just top it at 1.67, that I get a maximum value of about 5.63. In calculus, you'll learn how to actually find what value of x and what value of y this is precisely. If you use the minimum function, it will do a local min. Here it occurs exactly at x equals 0. Here, where is it increasing or decreasing? If you identify that the maximum occurred here at 1.67 and the minimum occurred here at x equals 0, well, I know now that I'm decreasing until x equals 0, and then I am increasing until I hit x equals 1.67, and then I'm decreasing again. And they cut off their window from -3 to 3, which is why their intervals start at -3 and end at 3. Okay. That's a real quick little video. I just want to make it separate because average rate of change is a sort of final topic that will have its own short